Okay, continuing to module 2.3, modeling is in state-based, and the second question. Okay, so the first question we tried was related to, let's have a look back, is, well, defining the zero input response of the system. Now, we are trying to look for the state of the system given at the end of 1 second. Okay, so let's identify the equations first. So the initial condition, which means x of 0, is already given. Remember that the zero input response of the system is equal to either p times x of 0, or since I am referring to the Resolvent matrix as r of z, I'm going to multiply r of z by the x of 0. Okay, so now we know that that is the zero input response of the system. Let's continue identifying the equations in the state space model. So the initial conditions of the system is 2, 3. There we go. And the state of the transition matrix, which is already giving us the resolvent matrix or RZ, is equal to E raised to negative 2t, 0, and 0 E raised to negative t. Now, let's identify the zero input response of the system. Let's call it 0. Is simply E raised to negative 2t, E raised to negative 2t, 0, 0, and E raised to negative t multiplied by 2 and 3. Remember that multiplying matrices, we're going to multiply for first row with the first column. So this is going to be e 2e negative 2t and 0. And then 0 and e negative 3t. I mean, we're adding it, right? E negative 2t. Is it clear? This is clear. And this is 3e negative t, right? Okay. So now that we have the zero of the equation, or the zero input response of this given system, we now try to identify it, let's call it x of t, right? X of t, we already have the x of t. We, or x of t, evaluate it at 1 second. So t equals 1 of this equation, which would result in 0.271 and 1.100. That should be the answer for this second question. Okay.